Hello my dear students. So I have been discussing the questions given in your textbook, that is the grade 10 science textbook unit 16, changes in matter. In the previous chapter I discussed the first few questions of the exercise. Now I am going to continue with the questions. This is the sixth question. Describe the meaning of the following. So they have given some terms that we have discussed before. They want you to describe the meaning of the following. This is not a definition, students. You just need to describe what that means. The first one, electrolysis or electrolysis. If you take that word, it has two parts to it. Electro refers to electricity, and lysis or lysis means you separate, you divide a more complex substance into simpler forms. That is the meaning of lysis. So here what we do is, by providing electricity, we divide a compound into simpler components. For example, if you supply electricity to sodium chloride, that is fused sodium chloride or liquid sodium chloride, you can separate it into sodium metal and chlorine gas. So by supplying electricity, we separate it into sodium and chlorine. So that is the meaning of electrolysis. If we describe that, dividing a substance, or you can say compound, into simpler substances by supplying electricity, or with the supply of electric current, if you make a chemical reaction to occur, that is also known as electrolysis. So we can say by supplying current, a chemical reaction occurs. So as an example, if I write sodium chloride liquid is converted to sodium metal and chlorine gas by providing current. So here I have given you an example so that you will remember, because we can relate it with the activity series, the metals that are highly reactive. Normally they are extracted using the process of electrolysis. So here sodium is also a highly reactive metal. It is available as sodium chloride in seawater. We can separate that out from seawater, the salt, sodium chloride. Then the liquid salt, sodium chloride liquid, can be used in an electrolytic process to separate out or extract out sodium metal. So that is for electrolysis or electrolysis. Then the process of reduction, or what we mean by reduction. Again, you are familiar with an example. When we discuss the metal extraction of iron using the blast furnace method, what did we do there? We discussed all the reactions. There you can remember carbon monoxide is a reducing agent or a reductant. With that, we separate the metal ion. So in that reaction, if you consider the hematite is the iron ore, that is Fe2O3. In that, iron is present in the form of Fe3 plus ions. So there, what happens is when you react it with carbon monoxide, iron becomes Fe. So the Fe3 plus ions in iron hematite takes up electrons and becomes Fe. And that reaction is known as reduction. So basically, a species taking up electrons during a chemical change or chemical reaction is known as reduction. So for example, if we take as an example, if we consider the reaction in extraction of iron. What do? We have Fe2O3 plus carbon monoxide giving 2Fe plus 3 CO2. So we need 3 carbon monoxide molecules. And this is the reducing agent. Why? Because it reduces the iron. Now if we consider this, now this iron is in the form of Fe3 plus. But when you get the product, you get Fe. So for Fe3 plus to become Fe, it needs to take up 3 electrons. We will be discussing these types of reactions, oxidation and reduction, in your next grade as well. We'll be discussing in more detail. But for now, remember, an ion, or it can be an atom, when it takes up electrons and forms a new species, that is known as reduction. Same way, you can remember the formation of sodium chloride, the ionic bond. How does that happen? Sodium loses an electron and forms the Na plus ion, a cation. Whereas you can remember chlorine takes up an electron and forms the chloride ion. So here also Cl takes up an electron and becomes Cl minus. This is also reduction. That is reduction. So when a species, it can be an atom, it can be an ion, it can be a part of a molecule. Now here it is part of a molecule. This ion Fe3 plus is part of a molecule. So that taking up electrons and forming the product, that part is what we call as reduction. So I am sure you all can understand that, students. With that, I will move on to the next slide. So here we have the 6th one. Describe the meaning of the following. In that, the next term is corrosion of metals. So when we say corrosion of metals, now when you have the metal, if you keep it exposed to air. Now a property of metal is that it has the lustrous nature. What is luster? The shine of the metal surface. But when exposed to air, this metal reacts with oxygen in air. Because of that, it tarnishes. And that is what is known as corrosion. So here we can say change in nature of metal like tarnishing, tarnishing when exposed to oxygen in air. So here of course it is oxygen in air, but even if you say when exposed to air is known as corrosion. Is known as corrosion. So here again, if you can remember magnesium, when it is stored in the lab, the shine is lost and also the magnesium oxide layer forms. So that is corrosion of magnesium. So as an example, I can say corrosion of magnesium, corrosion of magnesium metal when stored in the laboratory. Initially the shine is lost, then you know the magnesium oxide layer forms over it. So all that is part of corrosion of magnesium. Then the next one. What is the meaning of tarnishing of metals? I just explained that to you all. Normally the metals have a luster. When they are exposed to air, if the luster is lost, that is the shine is lost, then we say the metal is tarnished. So that is the meaning of tarnishing of metals. So here we can say losing of metals, losing their shine, or what you can say luster, when exposed to air is known as tarnishing. So that is what we call as tarnishing of metals. Then we have the last one, extraction of metals. What is extraction of metals? Now there are some metals that exist as native metals. Example, silver, platinum, gold. Even they exist with impurities. So we need to use very simple physical methods to separate them from their impurities. But the other metals, metals that are highly reactive and the metals that are moderately reactive usually exist in the form of compounds in nature. So normally they are present in their ores or in the form of compounds. We need to separate that metal in the metal form from those compounds and ores. So that process is what we call as extraction of metals. So here we can say separating the metal from their naturally existing compounds or ores. So here again, for example, extraction of iron from hematite. Using the blast furnace. That is one. Like we discussed in the previous slide, electrolysis. Electrolysis of sodium chloride is used to extract sodium. So those are all different processes of extraction of metals. So basically separating the metal from their naturally existing compounds or ores. So example is extraction of iron from hematite using the blast furnace. So with that, students, I have explained all the terms that were given to us. Describe the meaning of the following terms. Here, of course, I have not written an example. Tarnishing of metals. Metals losing their shine or luster when exposed to air is known as tarnishing. So for that also, you can even write the example. Magnesium strips lose their shine when stored for some time. Or else you can remember the activity that we did in the lab. When we cut a piece of sodium and we exposed the freshly cut piece of sodium to air, you were able to see that tarnishing. That was a very fast reaction. So you can write that also as an example. So here, students, we have explained we have actually described the meaning of the following terms. So in that corrosion, I explained that to you all. Then we have tarnishing of metals. Now only I wrote the example. So tarnishing is metals losing their shine or luster when exposed to air is known as tarnishing. And as an example, we considered magnesium strips lose shine when stored for some time. When they are stored for some time, so there should be a D, stored for some time, they lose their shine. And like I told you all, even sodium, because it's highly reactive, it quickly loses its shine. So there the reaction is fast. So that is tarnishing of metals. Then extraction of metals is how we separate the metal from their compounds. So I'm sure you all were also able to explain all these terms easily and you all did it correctly. So with that, we will move on to the next question. Question number 7. Answer the following questions on extraction of iron. So you're familiar with this process. We discussed this in detail using the blast furnace. We use the raw materials, hematite, limestone, and also we use coke. Coke is carbon. So those are the raw materials. From there, carbon monoxide is produced. That is the reducing agent that reduces iron from its ore, hematite. And thereafter, the impurities that are present with hematite, that is silica, SiO2, silicon dioxide, and alumina, that is aluminium oxide, Al2O3. They react with calcium oxide, that is formed from the decomposition of calcium carbonate, and they form the slag. And you all know, students, slag is useful when it is present over molten iron inside the blast furnace. It prevents further reaction of molten iron with impurities or oxidation of molten iron. So that becomes an advantage. You all can remember all the reactions related to this process. So now let us answer the questions given to us. Write separately the raw materials, main product and byproducts. So what are the raw materials? I just told you all that. Raw materials are hematite, that is Fe2O3. Then we have limestone, that is calcium carbonate, and coke, that is carbon. Now here, students, you don't have to write the name and the chemical formula, but I have written it so that you can remember all of these. You can either give the name, that is more better, and you can include the chemical formulae or the symbol of the element if you like. Otherwise, it's okay, only the names. So those are the raw materials. Then what is the main product? Main product. The process is to extract iron. We do extract it, but in the form of molten iron or liquid iron. So here main product is molten iron, or you can say liquid iron. molten iron or liquid iron. That is the main product. Then we need to write the byproducts. What are the byproducts? One is carbon dioxide. Now students, you all can remember in the first reaction, carbon reacts with carbon dioxide reacts with carbon and it is converted to carbon monoxide that is used as the reducing agent. But after carbon monoxide reacts with hematite, an iron is extracted, then we discuss the reaction where calcium carbonate decomposes. So there again carbon dioxide is released. And there, if you can remember, I mentioned to you all, now part of this carbon dioxide, when the reaction is continuing like a cyclic process, that carbon dioxide also can react with carbon again and form carbon monoxide. But if there is excess carbon dioxide, you can remember the structure of the blast furnace. There are outlets to remove the waste gases. So, carbon dioxide and other gases that can be present in the blast furnace due to impurities, they can be released through those openings. So, there the gases, waste gases or even carbon dioxide inclusive is a byproduct. In addition to that, I mentioned the slag. What is slag? Calcium aluminate and calcium silicate together. That is also a byproduct. So, there are two byproducts. Here we can say byproducts . I will write it here. Slag contains calcium silicate and calcium aluminate. Both together is what we call as slag. This is calcium silicate and that is calcium aluminate. And also we can say waste gases. So if there is excess carbon dioxide, that can be released from the blast furnace. So, those are the byproducts. They wanted us to write the raw materials, main product and byproducts. Raw materials, hematite, Fe2O3, limestone calcium carbonate and coke carbon. Main product is molten iron or liquid iron. And the byproducts are slag, that is calcium silicate and calcium aluminate together, and waste gases. If there is excess carbon dioxide, there can be other gases, but we did not discuss that in the procedure. So, if you write these are more than enough. So, then I will move on to the next part of the question. Answer the following questions on extraction of iron. The second part of it. What are the two methods by which carbon is obtained to produce carbon monoxide that reduces hematite? Here students, there is a mistake in the question. This should not be carbon, it has to be carbon dioxide. Because you all know in the procedure, we don't produce carbon. We actually use it as a raw material. Coke is carbon, that is a raw material. So when coke reacts with oxygen, we get carbon dioxide. That is one way of getting carbon dioxide that is used to produce carbon monoxide. So they have asked us what are the two methods by which carbon dioxide is obtained to produce carbon monoxide that reduces hematite. So one method is reaction of carbon with oxygen. So we can write the reactions. Carbon with oxygen gas produces carbon dioxide. Here the reaction is balanced. Then what is the other reaction? Limestone. When limestone decomposes, calcium carbonate is limestone. It decomposes to give calcium oxide and carbon dioxide. So calcium carbonate decomposes to give calcium oxide and carbon dioxide. That is the second reaction. So two reactions. Carbon and oxygen giving rise to carbon dioxide, calcium carbonate decomposing to give calcium oxide and carbon dioxide. So those are the two reactions that give rise to carbon dioxide. That is again used to produce carbon monoxide. So I'm sure you were able to write these reactions. With that, we'll move on to the next one. Again, the seventh question, answer the following questions on extraction of iron. How the temperature in the blast furnace rises to 1700 degrees Celsius, though the gas admitted to it is heated to about 650 degrees Celsius. This is a question or this is a concept that I did discuss before, students. Now we send in hot air. You can remember the hot air blast. That is through the bottom of the blast furnace. The hot air goes up. It helps to provide a temperature. There only the reactions take place. Now when this hot air blast is sent in, the temperature ranges from 1000 to 1900 degrees Celsius. You can remember that. And at the bottom, it is about 1900 degrees Celsius. As you go up, the temperature decreases to about 1000 degrees Celsius. Now, this increase in temperature is caused by the combustion of carbon coke. Now, coke is a type of carbon, and when that burns, it releases a high amount of heat energy. That is why the temperature rises up to about 1700 degrees Celsius. So, that is what we need to explain here. So, we can say coke, that is carbon, reacts with oxygen to form carbon dioxide. This reaction evolves a high amount of heat. This helps to increase the temperature of the furnace to about 1700 degrees Celsius. Or in other words, you can say combustion of coke releases a high amount of heat. So that is also okay. You can write it this way, or you can say combustion of coke releases a large amount of heat that increases the temperature. The temperature of the furnace. So either way you can explain this. How the temperature goes up to 1700 degrees Celsius, although the hot air blast is only about 650 degrees Celsius. So that is the purpose of using carbon coke. So here we can see coke, that is carbon, reacts with oxygen to form carbon dioxide. This reaction evolves a high amount of heat, and this helps to increase the temperature of the furnace. This has to be about 1700 degrees Celsius. Or else we can say combustion of coke releases a large amount of heat that increases the temperature of the furnace. So I'm sure you also would have explained this, but I did explain the combustion of coke and the releasing of high amount of heat when we discuss the extraction of iron. So this is the explanation there, students. So with that, we will move on to the next slide. Then the same question, part 4. I'll read the question here. Iron is formed from hematite. So here again, it has to be hematite, H-A-E-M-A-T-I-T-E, by the following reaction. And the reaction is given to you, Fe2O3 plus 3 carbon monoxide, giving rise to 2Fe plus 3 CO2. And the questions under that, if the mass of hematite reduced is 100 kilogram, calculate first one the mass of iron produced, the mass of carbon monoxide used up, and the mass of carbon dioxide released to the atmosphere. So we discussed a similar example when we discussed the uses of a balanced chemical equation. So here students, you are familiar with this equation. This is where iron is reduced from its O and the reducing agent is carbon monoxide. The equation is balanced. So how do we use that? We need to find the mass of iron, carbon monoxide and the carbon dioxide released if we use 1000 kilogram of hematite. So to do that, you all know we need to calculate the molar masses of all these substances. In your textbook, the relative atomic masses are given, so I am sure you know those values. Iron is 56, then carbon 12, oxygen 60. Those are the relative atomic masses of these elements. So using that, we can calculate the relative atomic mass of hematite, Fe2O3. How do we do that? We have 2 atoms of iron into 56 plus 3 oxygen into 60. So you will get this as 112 plus 48. That is going to be 160. Then if we calculate for carbon monoxide, that is of course easy. Carbon 12, oxygen 16. So directly you get the value as 28. 12 plus 16, 28. The same way if we are to calculate for carbon dioxide. Carbon 12, but there are 2 oxygen atoms into 16. So that is going to be 12 plus 32, 44. So those are the relative molar masses of these compounds. Then, if we use the equation. Now, you all are familiar with the equation. Fe2O3 plus 3 carbon monoxide gives rise to 2 iron plus 3 CO2. In this, if we take the ratio between the reactants and products, you all know this is 1:3:2:3. That means if we use 1 mole of Fe2O3, we get 3 moles of carbon monoxide and 2 moles of iron plus you will get 3 moles of CO2. So if we are to calculate the masses, we have already calculated the molar mass or the relative molecular mass and we know the number of moles. So if we use 160 grams of hematite, because you can see for hematite we calculated it as 160. So 1 mole is 160 grams of hematite. How many moles of carbon monoxide do you need? Carbon monoxide is 28 grams. If you take 1 mole, it is 28 grams. We need 3 moles. So that is going to be 3 into 28. That will be equal to, it's going to be 84 grams of carbon monoxide. So if we do that, now iron is 56. We have 2 moles of iron. So 2 into 56 that is going to be 112 grams of iron, and we will get 3 moles of carbon dioxide. So we already calculated carbon dioxide is 44. So that is going to be 132 grams of carbon dioxide. So if you want to use 160 grams of Fe2O3, you will need 84 grams of carbon monoxide. You will get 112 grams of iron and 132 grams of carbon dioxide will be produced. So in this, according to the question, you can remember they said 100 kilograms of hematite. 100 kilograms of hematite. So that is the question. So we need to calculate the rest of the substances for 100 kilograms of hematite. So then, if we do the calculation there, we have 100 kilogram of hematite, Fe2O3. That is equal to 100 into 1000 grams. So, 100,000 grams of hematite. So, if we calculate, either you can convert that to grams and do the calculation, or you can convert these to kilograms. Either way is okay. So, if we try to find the amount of carbon monoxide needed. So, there carbon monoxide needed is what? If you want to reduce 160 grams, you need 84 grams of carbon monoxide. So, for 160 grams, you need 84 grams of carbon monoxide. Therefore, for 100,000 grams. If we simplify this, so we need to divide 84 by 16. So, I'll do the calculation here. 84 divided by 16. So, here if we put 5, 80. So, we have 40, that is 2. And if we have 80, it's going to be 5.25. So, the 5.25 into 10,000. But if we want to convert it to kilograms, so this is going to be grams. We can convert it to kilograms. 5.25 into 10,000 divided by 1,000. So then of course you will need 52.5 kilograms of carbon monoxide. That is the amount of carbon monoxide that we need. Is that clear, students? So like that, if we calculate the amount of iron that we will get. So there amount of iron extracted, what is that going to be? So, if you take 160 grams of hematite, you will get 112 grams of iron. That is what we calculated before. Here we are using 100,000 grams of hematite. So, that is how we do the calculation there. So, here again, if we try to simplify this, if you are to divide 112 by 16, we can simplify it by 4, 8. So, that is going to be 7. This will be equal to 70,000 grams or 70 kilograms. So if we use 100 kilogram of hematite, we will get 70 kilogram of iron extracted from that. We also need to calculate the amount of carbon dioxide that is released. So if I go back and check again, there you can see 132 grams of carbon dioxide is released when we use 160 grams of hematite. So then, if we calculate amount of carbon dioxide released, so that is equal to, if you take 160 grams of hematite, there will be 132 grams of carbon dioxide released, but here we have 100,000 grams. So again, to simplify, 132 divided by 16. So if I do the calculation here, when we have 132 and 16, 33. So if we divide 33 by 4, so 8.25. So the value is going to be 8.25 into 10,000, that is 825. So 825, that is 82,500 grams, or else we will get 82.5 kilograms. So those are the amounts of substances that we will get. So if I go back and show you all the calculation, so here you can see, students, the question: iron is formed from hematite by the following reaction: Fe2O3 plus carbon monoxide giving rise to Fe plus carbon dioxide. So there they wanted us to find the mass of iron, carbon monoxide and carbon dioxide when we use 100 kilogram of the hematite ore. So there we need to use the equation. First we need to calculate the molar masses or the relative molecular masses that I have done here. Fe2O 360, carbon monoxide 28 and carbon dioxide 44. Thereafter, we calculated the ratio using the equation, and then using that you need to calculate each substance. So since we have the molar mass in grams, whereas the amount of hematite is in kilograms, either you can convert the grams to kilograms, or like I have done, kilogram to grams, and then do the calculation. So you will get the answer. Whatever the unit conversion you do, you will get the same answer. So we will be needing 52.5 kilograms of carbon monoxide, or else we will get iron, that is 70,000 grams or 70 kilograms of iron, and also there will be 82,500 grams of carbon dioxide evolved, or 82.5 kilogram of carbon dioxide evolved. So I am sure, students, you all also did these calculations correctly and you would have got the same answer. So with that, students, I will move on to the next question. Question number 8. Some instances which use gases are given below. Write the gas used in each of these instances. So we have discussed 3 gases: hydrogen, oxygen and carbon dioxide. And you all know the uses of these gases. The first one, formation of carbonic acid. You can remember when we make or when they manufacture fizzy drinks and soda water. Carbon dioxide is dissolved in water, so it becomes carbonic acid, which gives that sweet taste. So there the gas involved is carbon dioxide. The gas involved is carbon dioxide. Then the second one, facilitating respiration of critically ill patients. Normally you all know we need oxygen for breathing. We can fill them into cylinders, and these oxygen cylinders are used by many people for different purposes. One of them being facilitating respiration of critically ill patients. In addition to that, you can remember students, if they go for mountain climbing, deep sea diving or space travel, then also they use these oxygen cylinders. So here it is O2 gas. Then making dry ice, that is carbon dioxide. By carbon dioxide gas on cooling solidifies. It does not become a liquid, it directly solidifies, and on heating the carbon dioxide solid becomes carbon dioxide gas, and that has a temperature of minus 77 degrees Celsius. Carbon dioxide solid has a temperature of minus 77 degrees Celsius. So that is why we call it dry ice, and it is used as a supercooler. So making dry ice is carbon dioxide. Then the fourth one, using as raw materials to produce ammonia. What is ammonia? Ammonia is NH3. So to produce ammonia, we need to react nitrogen gas with hydrogen gas. So there we need to use hydrogen gas. Using as raw materials to produce ammonia is H2 gas. Then the fifth one, making margarine from vegetable oils. So to produce margarine, in the manufacture of margarine, we use hydrogen gas. That is a use of hydrogen gas. Then aiding respiration during diving. Already I told you all, deep sea divers usually take oxygen cylinders. So that is oxygen gas. And the seventh one, supporting combustion of firewood. So when we consider all three gases, hydrogen is a combustible gas. It burns in air. Whereas carbon dioxide is a non-supporter of combustion. But oxygen is a supporter of combustion. So we need oxygen to support combustion of firewood. So that is oxygen. So here students, we have written the relevant gases. Formation of carbonic acid, carbon dioxide. Facilitating respiration, oxygen. Then dry ice, carbon dioxide. Producing ammonia, we need hydrogen gas. And in margarine, production of margarine, we need hydrogen. Again, for diving, respiration during diving, we need oxygen, and supporting combustion of firewood, that is also oxygen. So I am sure you all wrote down those gases correctly. With that, I will move on to the next question. Question number 9, that is the question given in your textbook, the last question. The figure illustrates a part of a set of apparatus assembled to collect a certain gas. So if you look at the diagram students, you can see this is given to you. Here you can see a conical flask with a stopper attached to it. You can see the thistle funnel and a glass delivery tube. And here you can see there is a solid substance given to you, that is labeled as Y, and they have shown a liquid being poured into the thistle funnel, that is labeled as X. So you can remember, out of the three gases that we produced in the lab, we produce hydrogen when we react zinc with hydrochloric acid, a metal with hydrochloric acid. It can be that. Or else we produced carbon dioxide. There what did we do? We used calcium carbonate solid and we used dilute hydrochloric acid. So that is also possible. One of the two gases can be prepared or produced using this particular apparatus. So there, we will look at the questions. There is a fault in this set of apparatus. What is it? So look at the apparatus carefully. What is the fault? Now look at this part. Both the thistle funnel and the delivery tube are almost at the same level. You all can remember when I explained the apparatus, I told you all the thistle funnel has to come right up to the solid components there, so that it falls onto the component, it does not spill or enter into the delivery tube. So because of that, that has to come down, right down, and also when the gases are released, they go up. So because of that, when we have the delivery tube up, only the gas that is released will enter into that and will be delivered and collected in the gas jar. So the thistle funnel has to be right down and the delivery tube has to be above the reaction mixture. So that is the mistake that you can see in this diagram. So that is what we have to write here. The thistle funnel has to come down further and the glass tube, glass or you can say delivery tube, should be higher than shown in the diagram. So that is the mistake. Okay. So the next one, write 2 ways of setting this apparatus overcoming the fault. So basically we need to have a huge more distance between the thistle funnel and the glass tube. So already what I have mentioned there, if you adjust that, then you can overcome the problems. So here we can say one thing, the thistle funnel has to be or should be pushed, or we can say brought further down. That is one change you can do. And the second one, the glass or delivery tube should be moved up a bit more. So those are the 2 ways of setting this apparatus to overcoming the fault. You have to bring the thistle funnel down and you have to push the delivery tube up. So those are the changes that you need to make. With that, students, I will move on to the next slide where we have the rest of the questions. So here the third one. Suggest another method to collect the gas without changing the arrangement of equipment. Suggest another method to collect the gas without changing the arrangement of the equipment. So here we have this method. There you can see the delivery tube comes. So we will be using the downward displacement of water there. So if we are to suggest another method, it will be the displacement of air. We can use the displacement of air. That is another method that can be used. And if you look at the question also, students, they haven't mentioned about the method that is used to collect the gas, but from the diagram, you all can understand that we use it to collect the gases using the downward displacement of water. So the other method, suggest another method to collect the gas without changing the arrangement of the equipment. So there we can use downward displacement of air. So here again, students, you have to remember they say without changing the arrangement. So the delivery tube has to come down. If we are using upward displacement of air, then of course it will be somewhat different. So here we are doing downward displacement of water according to the activity. The other method can be downward displacement of air. So there is not much of a change. Only thing, you don't have to have a gas jar filled with water, as well as you don't have the trough and all that. You only need to have the gas jar with air. So it's going to be downward displacement of air. Then the fourth one, adding a rubber tube, a gas jar and a trough of water, draw the figure of a complete set of apparatus that can be used to collect the hydrogen gas. So here we need to draw the setup, adding the rubber tube, gas jar and a trough of water. We have the conical flask. Then we have the cork here. We need to have the thistle funnel. Then we need to have the delivery tube there. So here this is the thistle funnel. We need to have the trough. In that we will have the so here the rubber tube comes into this, and we will have water here. So this is water, this is the gas, we have the trough, then we have the beehive shelf, and there is water here also, and this is the rubber tube. So you have the thistle funnel, conical flask. So here we have the solid substance with the solution there, that is the acid. So normally it is either the metal and acid or the calcium carbonate and dilute hydrochloric acid. So this is how you are supposed to draw the diagram to collect hydrogen gas. So since they have said it is hydrogen gas, this is going to be zinc and HCl, dilute HCl. So that is what we need there. So with that, students, I will move on to the next part. These are the last parts of the question. The fifth one, name a substance each for X and Y that can be used to prepare hydrogen. So if it is hydrogen, you know it has to be zinc and hydrochloric acid. So X is the acid, so it has to be dilute hydrochloric acid, and Y is zinc granules. You can also have sulfuric acid, that also has to be dilute sulfuric acid, and instead of zinc you can have magnesium metal. So zinc or magnesium with dilute hydrochloric acid or dilute sulfuric acid can be used for this reaction. Then the sixth one, what gas could be expected to form if X is eggshells and Y is a solution of vinegar? So eggshells is calcium carbonate, vinegar is acetic acid. So when calcium carbonate reacts with acetic acid, what is the gas produced? Carbon dioxide. So here it will be carbon dioxide. Carbon dioxide. And the last one, a sample of the gas in part 6, that is here. Part 6 is collected in a test tube. Write how it could be identified. So, if it is part 6, this one, that is carbon dioxide gas, how do we identify carbon dioxide? When we pass carbon dioxide into lime water, the solution becomes milkier. And when we keep on passing it for a long time, again the solution becomes clear. So, from that we can confirm that it is carbon dioxide. So, here we can say pass the gas. So, here it is carbon dioxide into a test tube containing slaked lime solution. That is calcium hydroxide, and it becomes milkier. Then if you keep on passing more gas, the solution becomes colorless. This confirms that the gas is carbon dioxide. So, that is the test used to identify carbon dioxide. They have said the gas in part 6, that is where you use eggshells and vinegar. So, there the gas is carbon dioxide. To identify that, we use calcium hydroxide or slaked lime solution. That is colorless or slightly milky, but with carbon dioxide it becomes milkier, and when you keep on passing carbon dioxide, the solution becomes colorless again, and this confirms that the gas is carbon dioxide. So, with that, students, I have completed all the questions given in your textbook. So, I am sure you were also able to answer all these questions correctly. If not, with my discussion, you would have got a very good understanding of all the concepts related to this lesson. So, with that, I will end this chapter, and in the next chapter, I will discuss some extra questions with you all.